I want to give a summary first about what we've done and then give you a theory. And you got to know this theory. It is emanating from everything that we've done so far today. Number one, if the primal model is unbounded, the dual is infeasible. Check it. Now, one of the things we learned about the infeasibility, okay, and unboundedness was that you all remember infeasible. Infeasible is when you cannot find the decision variables. Now, the opposite of infeasibility in the primal is unboundedness in the dual. Keep that in mind. These are sometimes one of your IA questions. All right. So you got to note that. Okay. Infeasibility in the primal will cause unboundedness in the dual. Now, the next theorem is a complementary slackness theorem. The complementary, that one is tricky. Okay. But it comes from all that we have done. The theory connects the optimal primal and the dual solution. So the optimal values, the optimal solution point in the primal and the dual solutions in the dual are connected. And you got to listen here. Now, the primal that we did for Farmer Ghana Limited, the optimal solutions were 24 and 8. Do you remember? 24 and 8. Those were the values of fan yogo and fan choco. Those were the amount of fan yogo to produce and the amount of fan choco to produce. But when it comes to the dual, the Y1 and the Y2 deals with the price you pay for the labor, the price you pay for the milk. Those are called dual solutions. Now, we haven't worked that one, but you're going to see when you work it. I'll give you the extra when you work it. You will notice that the values are going to be the shadow prices. The values for those things are going to be 8 and 16, the shadow prices. So here's a rule. We are connecting the optimal solutions of these two, the primal and the dual. The theory assumes that if the primal is a normal maximization problem with the variables x, 1 all the way to m, okay, less or equal to the constraint, okay, then we can let S1 be the slacks. And we know this already because the S1, the S2 are the primal slacks. In that case, the dual will be a normal minimization problem with the variables y with a greater than the right-hand side of constraint. And so we can also create what? Surpluses, you might call, or excess variables for the dual, okay, for the excesses that will pop out, and we'll call them E1 to En. The theory now says that given all of these conditions, this is the theory. If we let X, the matrix of X represent X1 to N, if that is feasible primal solution, that is optimal solutions for the X are feasible, and then you have Y being a horizontal matrix like this, that will be the dual feasible solution. Then in that case, the X is a primal optimal, Y is a primal, Y is a dual optimal. If and only if, listen carefully, if and only if the slacks are 0 in both cases. That's what we've written there. If and only if the slacks are 0. And I'm talking about slacks, I'm talking about the weighted slacks. If the weighted slacks are all 0. That is only when we say that the optimal primal is a true optimal primal and the dual optimal is a true dual optimal. Okay. And that is a complementary slackness theorem. So in short, the complementary slackness theorem is trying to say that you don't just want to find the optimal solutions, but the optimal solution should be purely optimal when their slacks are 0, or in the case of the primal dual, in the case of the dual optimal, when the excesses or the surpluses are 0. When the surpluses are 0. Christopher, the way you've done your face and done your chin, I can see that everything looks like Hebrew and Latin all combined together going on in your head. That is what I see. but just go and read it. But the basic thing is that don't just tell me that this is the X values, but they are X optimal values provided the slacks are 0. That's all. Provided the slacks are 0. And when I say the slacks are 0, I'm talking about the primal. Or provided the excesses are 0. When I say excesses are 0, I'm talking about the dual. Complement, that's what he's saying. Complementary slackness. The slacks complement each other. If you're telling me that one is unbounded, the other is infeasible, then when the slacks are 0 here, the slacks must be 0 there. That's all. That's all. Anyway, this is the primal model for the FMGL Ghana Limited we have been using all these years. This is it. If you put this thing in Excel, you'll find a solution. This is a dual. This is a dual model that we just did some few minutes ago. Let's solve this dual in Excel. This is what you do. The same approach, you put it in Excel, solve it. Okay, you can do this on your own. Solve it, and this is what you get. Watch the minimized price. You can see that the total minimum cost is 1,360. And if you can remember, that was also the total profit for FMGL Ghana Limited. Do you remember? That was the same thing. Now look at the optimal values for the dual model. You see the Y1 is 16 and the Y2 is 6. Now who can tell me what the 16 stand for? And who can tell me what the 6 stand for? Because that will tell me that you understand everything we have done today. What does the 16 stand for? And what does the 6 stand for? Who can tell me? What does the 16 stand for? And what does the 6 stand for? Francis Aqua. Francis Aqua. The Francis are plenty here.
Hello, Doc.
Yeah, we got to me. What is this stand for?
Hello.
Go ahead and talk.
Doc, my internet was disturbing, so at a point I wasn't really following. So.
All right, let me go to Judah. Judah, what does the 16 stand for? What does the 6 stand for? Francis, don't worry again. Go ahead, Judah.
So I'm not too sure.
So that's the answer for your work. You are not too sure.
So as it stands now is.
Okay, Kweku Ahin. What does that?
Please, Doc, please, I want to try.
Okay.
I think that the Y1 stands for the price.
No, tell me the values.
Sorry, 16 cedis stands for the price for labor per unit. And then the 6 stands for the price for the milk per unit.
That's it. Basically, that's it. It's a price you pay for the labor, 1 hour of labor. So if you spare 1 hour of labor time, you're going to pay the price of 16 cedis for using my 1 hour. So that means that if you use my 2 hours, you will pay for 32. That's why, if you can remember the shadow price, we said that the right-hand side of the constraint for the labor indicates that if you increase labor by 1 hour, profit must rise by 60. And if you increase labor by 2 hours, profit must rise by 32, because that is the shadow price. So the Y1 here is a shadow price of labor. That is the price you will have to pay for using labor. That is it. And when you take that into consideration, you'll get there. So look at the constraint on the left-hand side and the constraint on the right-hand side. The right-hand side is the minimum price you pay. for that resource. And then the left-hand side is the actual price you paid. So the left-hand side can be more than the right-hand side. And when the left-hand side is more than the right-hand side, what it means is that you are paying the price more than the minimum. That is not good. That's why we are saying it's called excess. You are paying too much. Okay? If this 40 on the left-hand side here is 70, you have overpaid 30. And that 30 means that you have, you know, you are going to be inefficient. You are inefficient, actually. It means that you don't know the value of something you are going for. Your bargaining power is weak. And so that is why this will satisfy the complementary slackness approach, because you can see that there are no slacks here. There are no slacks, or in this case, there are no excesses at all. All right, guys, this is your assignment. So when you go and solve this, you get this whole solution. This is your assignment that you are supposed to submit in 2 weeks. Okay. This is assignment. Assignment is also in a Word document. Bernice.
Yes, Doc. Yes, Doc.
I've given you the Word document for this, right?
Yes, please.
Good. So upload and then give it to them so that they can supply it in 2 weeks.
Yes, please.